Hey everybody, and welcome to the solutions video for the notebook Boolean Indexing More. All right, so the first few exercises assume that you've read in the bikes data frame. So I'm going to go ahead and read that in. And we're going to parse the dates. So that looks good. So exercise 1, select the wind speed column as a series and assign it to a variable. Okay, we can do that. So wind speed. All right, so it says, and let's just output the head. It says, are there any negative wind speeds? So we can do this pretty simply by writing a one-line Boolean condition. We'll say, we'll make the filter here. We could break this in 2 lines, but it's so simple we might as well just put it in 1 line. We're going to select only the wind speeds such that are those that are less than 0. So if this is a proper data set, then we probably shouldn't have any negative wind speeds. But as we look here, there actually are, unfortunately, some negative wind speed. So this is probably, maybe a code for a missing value or something. But there's obviously not valid data. Well, let's move on. To select all wind speeds between 12 and 16. So this is good. This is a good use case for the between method. You can use Boolean indexing, but the between method does this in one shot. So we could say the dot between 12 and 16, and we could use this as our filter, and then we can just pass that filter into our brackets, and we'll get only those between 12 and 16. Now this is inclusive, so if there is a 12 or exactly a 12 or a 16, then it will be included by default. All right, exercise 3, select the events and gender columns for all trip durations greater than 1,000 seconds. So let's go ahead and make a variable here that will contain the events and gender column. And then we'll create a filter. We want all the trip durations greater than 1,000 seconds. Okay, so we want trip duration. Let's create this filter longer than 1,000 seconds. Okay, so this filter will filter out the rows. This column list will return just those columns. And we need to use the loc indexer to do simultaneous Boolean selection for the rows and column selection for the columns. So say filt, calls, and this should work. So I probably should have also put trip duration in here just so we could verify that. So let's go ahead and modify the question on the fly and make sure that our trip duration is indeed greater than 1,000. Okay, so it looks like that works for exercise 3. Exercise 4, we're going to read in the movie data set and set the index to the title. Then we're going to select all movies such that the Facebook likes for actor 2 are greater than those for actor 1. This is where we're going to do column by column comparison. This is the first time we've done this in one of the exercises. So we'll say actor 1 Facebook like. It says actor 2. So we want actor 2 Facebook likes to be greater than actor 1. So let's call that filt. So this will do a column by column comparison. So it's going to go through here and just check whether actor 1 is or actor 2 is greater than actor 1. If it is, then it will return true. So let's find out all the movies are that are here. And so this one actually doesn't have any positive results. So it looks like actor 2. For whatever reason, never has as many Facebook likes as actor 1. So it is scary to get 0 rows back, but it just so happens that they are all false. So which is a perfectly acceptable, Boolean condition. Something's going to evaluate as entirely false. All right, so it says select the exercise 5 now. Select the year, content rating, and IMDb score columns for movies from the year 2016 with IMDb score less than 4. Okay, so this is quite a mouthful here, but let's try it out. So in year, content rating, and IMDb score. So that'll be their column selection. And we're going to create a filter for the rows, and we'll say we want the year to be exactly 2016. So we'll just say set it equal to 2016. And we want IMDb score to be less than 4. So you know what, we're going to go ahead and make another variable here and just say the IMDb score will be less than 4. Okay, so now we're going to combine these two filters. So it says we want and, right? So it says with, yeah. So we need both of these filters to be true. So we'll say filt1 and filt2. All right, so there's quite a lot going on here. So we're saying we're going to select these columns. Then we're going to filter such that both of these, that both these conditions are true. The year is 2016 and IMDb score is less than 4. And finally, we can put it all together with the loc indexer. So we'll do movie.loc. And we'll say we want the filter and with just those columns. So it turns out there's actually not too many that it returns, only 3. I didn't do .head, so this is actually the entire data set. So these are from the year 2016 with an IMDb score less than 4 and just those columns. All right, let's move on to number 6. Select all the movies that are missing values for content rating. So we need the isInA method here. So let's go ahead and do that. Movie content rating. If we do isInA, this will return us a Boolean series. So only those that are missing it, so the ones that are true, and we can just pass in the filter there. And let's just do .head here. So this finds all the movies that are true or false for that have a missing value and then we actually make the selection here. So all of this column content rating should be missing, and it looks like it is. So that completes exercise 6. Exercise 7. Select all the movies that are missing both the gross and budget columns, and return just those columns to verify that those values are indeed missing. So this looks like we need to create 2 filters here. So we're going to do movie of the gross column. So we're going to check if that one's null. And then we are going to check if the budget column is also null. And then we will put them together. So we want both of them to be null. So this is going to be another AND operation. So we're going to use the ampersand here. And then it says just to return those columns, so let's go ahead and make a list of just those columns, and then we can put everything together. So this checks that both of them are null, and then we're going to use that filter and only return, and I forgot my precious loc indexer, and so that looks good. So both of these better be null. If I look through here, okay, so there's quite a few. Let's just put on .head and everything looks good for that. All right, so exercise 8 is probably one of the most involved problems. It says write a function called find missing that has 3 parameters, df, column 1, and column 2, where df is a data frame and column 1 and column 2 are column names. This function should return all rows of the data frame where column 1 and column 2 are missing. Only return the 2 columns as well. And then we can use this to answer problem 7. Okay, so this is actually just problem 7 wrapped in a loop, or wrapped in a function. So I'm going to go ahead and copy and paste this. So we're going to use, let's go ahead and define this. It says 3 parameters, find missing, so is the name of the function, df, call 1, and call 2. And I'm just going to paste our results from problem 7. So instead of gross, it can be any column. And instead of movie, you have df. So instead of budget, we have call 2. And the calls together, we'll just do call 1 and call 2. All right. So that looks good, but we need a return statement. And instead of doing .head, we'll just return all of them. Okay. So that appears like it should work. It's essentially just copying and pasting that and filling in all the hard-coded names with the variable names from up here. So let's go ahead and do this. Find missing. So our data frame is called movie. Call 1 was gross. Call 2 was budget. So let's see if this works. So good. Looks like it's worked out perfectly for us here. So that completes exercise 8, and that is the final exercise of this notebook. All right, so hope you enjoyed those solutions on Boolean, on Boolean indexing more.